Hi everyone. Uh, in this video, we will learn about remainder theorem. This is very important skill set to have when you are dealing with polynomials. Remember, I am using the word skill. In this video, we will discuss in detail about how remainder theorem is equivalent to a normal division process, and then we will go step by step at solving one example, and then I will go much detail about by comparing a normal division process to the example of polynomials which we do, and then we will do few practice questions so that you get the idea. I will request all of you to bring a pen and paper or whatever you have in hand and practice along with that, because this is a skill set which I have seen many students find it very difficult, because it involves a process of correlation between the normal division which you used to do and in the polynomial division. So, in short, if I talk about remainder theorem is nothing but a normal division of a numbers. But here in polynomials, when we do it, so we say it remainder theorem. That's it. Remember that for now. So, if you remember in class 3, 4, or very basic elementary algebra class, when you divide 5 by divided by 2, so how you do that? So, I'm doing it. You must be thinking why I'm doing it again, because you can see the comparison along with me uh, in polynomials, how the remainder theorem works. So, if I have to do a normal division, 2 divided by 5, then we will do 2 to the 4 and then 1. So means it 5 is not completely divisible by 2, and it is leaving this what this we call it, this we say as remainder, this we call it as divisor, the thing which is dividing, and this is quotient, right? I hope this much is clear to you. So coming back to this now, dividend is nothing but a divisor into quotient plus remainder. If I go by that formula, so what will happen? So the thing that will happen is that uh, so what will happen now for this case, we were getting uh, 5 divided by 2, so dividend, so dividend equals 2. So we got 2 2s are 2, yani 2 is a divisor, 2 we got as a quotient, plus 1 as a what, remainder, that is 2 2s are 4 into 5, means the number which is getting divided is nothing but a 5. Who is dividing it? By 2. How many times we have to go? Means quotient is 2. What is the remainder? 1. So why I am telling you all this is because the similar thing, remember this formula, similar thing we'll be doing in remainder theorem when we'll be dividing the polynomials. So let's create a frame here so that we can come back. Now the second one, yeah, that looks better, much better. Okay, so let's take this example. Now we have x plus 1 3x minus 2, or we have x plus 1 3x square plus x minus 1. So let me put it this way. What we need to do, so we need to divide 3x square Plus, say, let me just give one example. Plus x plus 1 is divided by x plus 1. This is what we need to do. So if you compare, x plus 1 is getting divided by 3x square plus x plus 1. Now we have to apply remainder theorem, means the same process of what we did in the normal division process, and then we have to go in step by step. So let's do it. So what we can do, we can write this as x plus 1 3 x square plus x plus 1. Now very important thing, why students face much more difficulty into this is because they are not able to visualize it. So let me do one thing. Remember this. This is x here. This is 3x square. Now suppose if I want to remove 3x square, means I have to dismiss 3x square. So what I should multiply? The same way you when you try to do this thing, that 5 divided by 2, then what you thought, that what could be the maximum possible value, means 2 twos are 4 is the maximum possible value, means 4 is what we can bring maximum. Similarly, these are the expressions. What we need to do is make it equivalent in somehow, that this term, so first aim is demolish this term anyhow. So what we can do, if this is x, means the power of x is 1 here, and here power is 2, means I need 1x definitely. Then x next will multiply, will result into x square, but here is 3 also, means we need to multiply with 3. So 3x when get multiplied by, let me erase this. Sorry about this, it's a digital thing, so I'm helpless. Please bear with me. I'll try my best to explain you this concept. Let me change the color. So yeah, now the thing is, let's remove this one also, so that we get some space. Okay, now see here, when this 3x will get multiplied by x plus 1, now this will result into 3x square. This is what we wanted, right? And then 3x will multiplied with 1 means plus 3x. So we will write that. So 3x will be okay. So we'll go with that. So that will result into 3x square plus 3x. Now for the second step, what we will do, as we used to do, we will do the subtraction. Change the sign here. So this 3x square will get cancelled, because here is the plus, here is a minus. So it will get cancelled. Now x plus into minus is minus 3x, will result into minus of 2x. So we will get minus 2x plus 1 is also remaining. Now 1 we couldn't counter because there were only two terms there. Okay. So 1 we have to write it again here. I hope that much is clear. Right. Now again what we will do, we will follow the same step. Right. We will somehow think that how we can remove this term. How we can remove this term. Let me change the color to pink one. Same step. The way we remove 3x square, we will think about what we should multiply now with x plus 1 now, so that we can remove this term. Only aim the first term. Don't worry about the last term. The same way I didn't worry about this x, because if you'll do that, you will get confused. The simple process is, now I want what? I want minus 2x here, right? So how I can get that? So here is x, so I can multiply. If I do this, think, think. If I multiply with minus, because I need minus sign, and if I'll do this 2, then do in a rough work that if minus 2, this is the only term that is getting multiplied with x plus 1, what it will result? That will result minus 2x, minus 2. So write it down. That will be minus of 2x, minus of 2. Now what we will do, we will do the again thing. We will change the sign, minus to plus and plus to minus. That will be plus. So this plus, because now this minus is not minus, now this is plus. This plus and minus will remove this minus 2x, and this is plus now. So plus 2 and 1 is 3. So what we are getting as a remainder, 3. What we are getting as a quotient, 3x minus 2. Now we can write the same formula, dividend. Remember, go here, see the formula again. That is dividend equal to divisor into quotient plus remainder. Now what is the dividend? The thing which is getting divided. Okay, that will be equal to I'm writing it here for much more clarity. That will be equals to 3x minus 2 when it will get multiplied with x plus 1. Remember this, the thing that will get added is nothing but plus 3. That is a remainder. So this is a remainder, this is a quotient, this is a divisor, the thing which is getting dividing this expression of polynomial 3x square plus 1. Now what you can do, just do one thing. This expression is nothing but it will turn out to be 3x square plus x plus 1. So you can do the multiplication here on your rough book and verify that. So let me do it for you, so you can do it with me together. So let's add another skin so that it is much clearer. Now let's go what we have, 3x minus 2, x plus 1 plus 3. Okay, so that's the pencil. Okay, now we have 3x minus 2 as a quotient, and that divisor is x plus 1, and what we got as a remainder is 3. So do this multiplication, that will become 3x square. You can do it by your own pace, and this will be getting multiplied with 1, that will be 3x. This will multiply it with minus 2, that will be minus 2 into x, minus 2x, and then 2 into minus 2, and this will remaining. So this is, are there any terms of 3x square, x square degree? No. So 3x square, are there term of x? Yes. So 3x minus 2x, are any other term of x? No. So 1x, and minus 2 plus 3 means 3 minus 2, that will be plus 1. This is nothing but what were trying to divide. See here, go back to the frame 3. See here, 3x square plus x plus 1, 3x square plus x plus 1. This is nothing but a remainder theorem. I hope you got the clarity. So the important thing is to understand that there will be some, why we do that. Now question arises, why we are doing this. So what will happen in the future classes in maths, physics? If you read in maths and physics, so you will get this type of divisor of polynomials, where you have to divide the polynomials. So for that purposes, when you have to simplify the polynomials in terms of factors so that you can bring out meaning out of that, like we can say this polynomial 3x square plus x plus 1 is a factor of 3x minus 2 x plus 1 but with a remainder 3. So similarly, you can divide that and you can bring meaning out of that. So in physics, there are certain meanings associated with such operations, or in math, you will be getting just a step to do that so that you can arrive at the answer much easily, because solving a higher degree will be much more tougher than solving a polynomial with only simplified terms. The most important thing is that we need to simplify this. X squared term is now in terms of x and x ki power 1. So that's why we need remainder theorem. It is nothing but a skill set, but it has lot significance. Even when you will be post graduating or anywhere where will be any kind of a math is involved with respect to the polynomials, you will get this type of expression and you have to solve that out. Solving means you have to simplify that. Means you have to uh, bring higher order term or the degrees into normal degree term. Means you have to represent them in terms of a factor with a remainder so that you can solve that out. Okay, so that's about that. This is nothing but a remainder theorem which I wanted to discuss. You can practice the examples. Let me do one example. Suppose the simplest one, let's pick it up so that we can quickly go through that. Okay, let's do this one. This x divided by x cube plus 3x square plus 3x plus 1. Okay, so let's do that. Let me give you that. So okay, sorry for that. Now suppose I am giving you example, say very simple example. Suppose you have to divide 3x cube plus, take it that example, okay, 3x square plus x plus 1 is getting divided by x, the simplest one. So do it with me. So the simplest procedure which we can follow is we can write in the same manner 3x cube plus 3x square plus x plus 1. Now remember what we need here. We need 3x cube, and here's x, means x ki power is how much? 1. How much more power you want? 2 more powers. So you need what term to multiply with that? X square. But if you multiply with x square, will this term will get cancelled out? No. You need one thing more, that is multiplier, that is 3. Because if you multiply with 3, that will become 3x square. Now in rough you can think about it. 3x square into x is nothing but, remember, 2 plus 1, that will be 3x cube. See, we can write it here, as simple as it. Now change the sign, that will get cancelled out. Now only this term will be remaining, so we will write that out, 3x square plus x plus 1. Similarly, again focus on this term. Think, now here the degree of x is 2, here is 1. So what we need to add on, that we can do is we can multiply it with only x. X into x will be x square, but we need multiplier how much? Think, 3. That will again 3x square x plus 1. So minus, that will be get cancelled. Again you need only x, that is x, so you don't need that. You can only do this plus 1. Now 1 multiplied with x will be x only na. So x, now x is gone, 1 is remaining. So 1 is a remainder now. So this is it, that's it. This is the quotient, this is the remainder 1 x. Now when we multiply, we can say it like that. When we multiply 3x cube plus 3x square plus x plus 1 divided by x, then we get a quotient as 3x square plus 3x plus 1 and remainder as 1. You can write it in that formula also and verify it out. Okay, so that's it. That's the whole purpose of doing such examples and questions, and I hope you must have understood it. So thank you for watching. If you have any questions and doubt, you can drop in the comment box. I will try to address that. Meanwhile, you can pause the screen and keep on trying all these questions. X plus 1 with this expression and x plus pi with this expression. The funda is very simple. Even see this. The power was 3 here. When it got divided, the power of x's, the term of x's got smaller. That's why we do the remainder theorem, and that's the aim. You have to understand right now this is a skill set of just dividing the polynomials into the simplest form. That's it. Simplest form in terms of the power will get reduced. Similarly, where the way when you were dividing 5 divided by 2, it was 2 twos are 4, right? So you can write it like this: 2 1 and 2, 2 twos are 4, and 1 is 5, so 5 divided by 2. Similarly, this is what we are trying to do. Remainder theorem is nothing but a dividing process of the polynomials to simplify the task. Remember. That's it. Thank you for watching. Bye.